Okay, so I apologize if this is getting uploaded a little bit late, but today's lesson is 7.01 on graphs. Basically, it's statistical type graphs. I noticed there was something funny in the PACE chart. It said problems 1 through 21 on pages 495, 497 of the student guide. That's incorrect. It should be of the reference guide. I'm hoping you guys figured that out once you open the student guide and realize, oh, there is no problems 1 through 21, and it says to do the reference guide. So hopefully you figured that out, but if not, there you go. Make sure that you're using the reference guide, not the student guide. So what I'm going to do here is show you some problems similar to the ones that are in the problem set, and just show you how I work through it, how I find the answers, okay? This is not by any means comprehensive because there are so many different kinds of graphs that you can get, but hopefully seeing how I deal with these three will help you guys. Okay, so here we have a bar graph regarding favorite color of a certain population. We want to know which color is most popular. In these graphs, what this is doing is it's saying these are the choices people made, all right? They chose red, orange, yellow, green, blue, or purple, and this Y column will represent the number of people who gave that response as their favorite color. So all I need to do to look to see which color is most popular is to look at the graph and say which one of these bars is higher, which one represents the most number of votes or people, and that would be this one for blue. So blue, 8 people chose blue, so which color is most popular? Blue, because it has the highest bar. Which is least popular then would be the lowest bar. So I look here and I say, oh, orange is the least, because of course, who likes orange as their favorite color? But I'm sure some people do. So only one person. You can see that it's 1 because it's halfway between 0 and 2. So only one person chose orange, so that is the least popular. Now for this question here, how many people chose yellow? What I need to do is find the bar that represents yellow and look at how tall it is. See, what height is that? This is halfway between 2 and 4, which is 3. So how many people chose yellow? 3 people chose yellow. Now this one's a little bit trickier. How many more people chose purple than orange? So I need to look at purple and at orange. I need to find out how many for each. So purple is 4, and orange is 1, as we already said earlier. So how many more people chose purple than orange? That would be the difference between the number of purple and the number of orange. So that would be 3, because 4 minus 1, 4 purple, 1 orange, 4 minus 1 is 3. How many people chose yellow or green? Think back to the probability stuff we did, and or usually means to add things. So we look at yellow and we say, oh, there's 3 there for yellow. And green, there are 4 for green. So people who chose yellow or green would be 7. 3 plus 4 is 7. Now, how many people were surveyed altogether? The number of people surveyed altogether would be the total number of all responses of any kind. So what I'm going to do here is look at red and say, oh, red is 5. Orange was 1. Yellow was 3. Green was 4. Blue was 8. And purple was 4. So 5 plus 1 plus 3 plus 4 plus 8 plus 4. 5 plus 1 is 6, plus 3 is 9, plus 4 is 13, plus, I'm going to do the 4 next, which is 17, and then plus 8. 17 plus 8 is 25, I believe. You can double check this with your calculator if you like, but I'm going to guess that I probably did this fine. That's 10. I'm going to recheck it. That's 22, 25. That's correct. Okay, so 25 people were surveyed altogether then. Now, what percent of people chose red? Remember that the percent of people who chose red would be the number of people who chose red divided by the total number of people surveyed. So I look at red and I say, okay, red was 5 people. Total number of people surveyed was 25. So 5 over 25. I'm going to reduce that fraction, which is 1 over 5, and turn it into a decimal, which is 0.2, and turn it into a percentage, which is 20%. Because remember, to go from a decimal to a percent, we move the decimal place 2 places to the right to do that. So there we go. Okay, here is another kind of chart or graph. This is a scatter plot, and this is not exactly what our class grades and hours look like, but this is actually close enough, so I thought that this would be hopefully educational. Mrs. Moore wanted to see if there was a correlation between her students' time spent in the course and their grade. I can tell you, yes, there is. What is the highest math grade? So what you want to look at here is, you can see that this is time spent in hours. This y-axis here is your grade, percentage of the grade. So what is the highest math grade? You want to find whoever is the highest of all the grades, right here. This person here has the highest grade, and we want to see it's practically on this line. I'm going to pull this all the way over here and say, okay, look, that is 2 marks above the 60, and we're going between 60 and 80. So this must, I'm guessing that these are 5% marks. Let's see, 5, 10, 15, 20, 25, oh, not quite 5. So what I need to do here is find out, first of all, how much each one of these little marks means. So I'm going to take the difference between 80 and 60, which is 20, and divide by the number of blocks between them, which is 1, 2, 3, 4, 5. So 20 divided by 5 is 4. So that means that each of these lines is worth 4. So now that I know that each line is worth 4, I'm going to count and see, okay, look, 64, 68. So that means what's the highest math grade is a 68%. Okay. How much time has the person with the highest grade spent? So I'm going to look down here and going to do the same thing. 60 to 80. 1, 2, 3, 4, 5 blocks there. Okay, so that means that, again, each one is worth 4. So, I'm going to look at this. Okay, 64, 68, 72, 76. So 76 and 80, that looks like it's about 1/4 of the way through. So that would be about 77. So how much time? 77 hours. What is the lowest math grade? Oops, sorry about that, guys. There we go. So what's the lowest math grade? If I look here, here's my lowest math grade. And again, I know I'm counting by 4s here. So if that's 4%, that means that that person is probably at about 1%, maybe 2%. Let's call that 1% because it looks to me like it's about 1/4 of the way, not half. So the lowest math grade is a 1%. How much time has the person with the lowest grade spent? Okay, well, I know it's counting by 4, so 4, 8, this would be 12. So it's halfway between 8 and 12. So that's, I'm going to say that that's probably about 10 hours. Good answers here would be 10 hours or maybe even 11 hours. Nah, closer to 10 hours really, so probably 10 hours. Okay, as the time spent increases, what happens to the grade? Overall, looking at this as a trend, as a set of data with a pattern to it, when the amount of time spent on the course increases, what happens to the grade? Well, you can see, and you can even draw a line. In fact, I'm going to do that to help me kind of approximate what's going on here. If I were to draw a line of fit through here, just approximate, just eyeballing it, I can see that as the time increases, the grade increases as well. Overall, obviously that's not true for every single person here, right? There are some people who, are spending a lot of time, like this person here is spending more time than other people perhaps, but their grade is lower. Like this person is spending less time but has a higher grade than this person. So that's going to happen. But overall, the data goes up, right? This line has a positive slope. So as the time spent increases, the grade increases as well. So to describe the correlation between the time spent and the grade earned, we would say that there is a positive correlation. We can also say here that there is a strong positive correlation, which means that the correlation is strong in that the data does actually follow the line pretty well. But definitely a positive correlation, because as the time goes up, the grade goes up as well. But everything's relatively close to that line, so we can also say it's a pretty strong correlation. Okay, now circle graphs or pie charts. This one is about gaming systems. I hope I took good guesses as to what responses would be, because obviously I haven't actually surveyed at 310 students. Okay, so students were surveyed to see what gaming system they preferred. What percent of students chose? What percent of students chose some kind of PlayStation? So some kind of PlayStation would include the PS2, right? The PS3 and the PS4. All three of those are PlayStations. So what students chose some type? Or how many students? 2% of students, plus the PS3 was 10%, plus the PS4 was 47%. So that would be 12 plus 47, which is 59. So 59% of students chose some kind of PlayStation. Excuse me. Sorry, I'm going to move this up so that hopefully it won't do funny things. What is the difference in percent between the students who chose the Wii and the PS3? So I look at the Wii and I say the Wii was 8% and the PS3 was 10%. So what's the difference between them? I'm going to take the bigger minus the smaller, which is 2%. So the difference between PS3 and Wii is 2% difference. Okay, so if 310 students were surveyed, how many of them chose the Xbox? Sorry about the typo there. So we want to know if 310 and the Xbox. The Xbox, if I look here, is 27%. 27% for the Xbox. So 27% of 310 is what we want to do. Remember that percentages are always written as a decimal when we use them. So 27% times 310 is 0.27 times 310, so I'm going to go ahead and calculate that. And that would be 83.7. Obviously I can't have a 0.7 of a person, so that I would round that to 84 people. 84 students. So 84 students must have chosen the Xbox if we were surveying 310 students. So we just multiply the percent times the total number of respondents, so total number of people who were surveyed. Okay, so there we go. You've gotten to see 3 examples of how I reason through and use the chart to get the information I need. Please do go back and do the reference guide problems 1 through 21 of the reference guide. Understand or notice that some of those problems, I think 2 of them actually have you building charts or circles. Just do the best that you can to sketch those. Do practice sketching them because you'll have to identify them on problem sets and in the tests, on the quizzes and in the tests. You know, like which one of these graphs fits this question or this situation. Okay. So again, 1 through 21 on pages 495, 497. The first 3 sets of questions are just like the bar graph, the scatter plot, and the circle graph or the pie chart. So hopefully those will help you to get quite a bit of that solid. And just do what I did. You know, be really careful. Ask yourself, for example, here you want to really look at, you know, the high levels and just look across to see how many each one is. If there's an or, you've got to add them. With the scatter plot, you know, one of the key things we did here is we did draw a line or sketch a line. You may not want to actually draw in your textbook, but you can use the edge of a piece of paper or very faintly with a pencil, just draw a really faint line to help you see what's going on. There was a lot of, you know, we had to actually figure out how much we're counting by for each of these lines. That's definitely something you need to do when you're looking at that graph, is find out how much am I counting by, and then look for, you know, highest, lowest, and what their corresponding x coordinates are. And the really big key on the circle graphs is really, you know, that you can add percents, you can subtract percents, but then you can also take a percent times the total to find out how many people actually chose, you know, number of people as opposed to percent chose a particular item. Okay? So please Try that, practice with it, and then take the quiz. Thank you.